Hello, my name is Austin, and I'll be giving a general overview and explanation of Group 5's project, Pixelland. Pixelland is a web-based game developed using JavaScript and HTML, more specifically using Canvas. It's a top-down game that takes inspiration from many games, but more specifically, games like Terraria and Minecraft, which include procedurally generated maps that allow the player to explore and discover new things in the map. I'll be introducing the main menu here today. So this is the main menu. We have Pixelland, which is the name of the project, and there's two buttons below it, Start Game and Load Game. Load Game is a feature that allows you to save and load the game whenever you want. That will be explained later in the demo, not something I'll be explaining right now. But what I can explain right now is the Start Game button. Pressing the Start Game button will take you to another menu, which shows you Pixelland again, which is showing the name of the project again, and choosing map. There's two maps you can choose from: Rainbow Land, which is our own take on this procedurally generated map and world thing, and you will see again later in the demo. And Minecraft, something many of you may be familiar with already. And yeah, I will not be showing either of those maps. That's for my group project to do, and I will send it off to them right now.
Hi everyone, so I'm Nathan, and I'm going to show you our first map, which was called Rainbow Land. So Rainbow Land is, as the name would suggest, a sprawling world of colorful gradients that are determined by a seed-based world generation algorithm that's used in all the worlds that we have for Pixelland. In this world, you can walk around and explore all the different colorful gradients. But in addition to that, you can approach these more contrasty blocks that don't quite fit in with their surrounding color hues. And on occasion, as you just saw, they will teleport you randomly somewhere else in the world. Now, say you're done for the day and you're done exploring the vast expanse of Rainbow Land. You can hit escape and you can save your game, close out your tab, go about your day, and then come back later, um, load up your game, and it will pop you right back where you left off.
Hello everyone, my name is Zach McCrae. In addition to the game's Rainbow Land map, Pixelland also features a map that might resemble your favorite childhood game, Minecraft. Although there are no creepers lurking in the dark, nor are there seemingly endless caves and strongholds to explore, the map still features a handful of aspects which take you back to the early days of childhood gaming. Our Minecraft map boasts textures such as grass, sand, stone, dirt, gravel, and flowers, as well as ores such as coal, iron, gold, diamonds, and more. All of these block textures are directly styled from Minecraft itself. In addition to these textures, the game also has a fully functioning inventory system similar to Minecraft, with hotkeys ranging from 0 to 9 for the individual storage of blocks. These hotkeys make up the hotbar, which is the long row of tiles on the bottom of the screen. The inventory can be accessed by pressing E, where a plethora of blocks are given to the player at the start of the game, similar to Minecraft's creative mode, without the flying, of course. These blocks can be clicked on and placed in the user's hotbar, where the player can then place them onto the ground with the left mouse click. You may have noticed that in addition to the hotbar and the placing of blocks, the map also resembles Minecraft's infamous range of biomes. These biomes are generated using algorithms, and each map has its own unique seed and its own unique map structure, which you will learn more about later. To see more of the beautifully constructed biomes, the user is able to zoom in and out using the plus and minus keys on your keyboard. You may use the arrow keys to navigate throughout the map, but be careful not to go too far. Watch as we now explore the little bit of the map.
Hi, I'm Sebastian, and I'm going to be demoing the development and debug modes of the game as well as our tech stack. So for our project, we wanted to have as little dependencies as possible, so we have a very simple tech stack. It's simple HTML, JavaScript, CSS, Canvas, and outside of our linters and prettification of our code, we have no external dependencies, and because of our linting, all of our code is standards compliant. And debug section of the demo. So what I'm going to demonstrate is the testing tools that we have to ensure proper function of the game. So to enable this mode, you go add an argument to the URL, title that argument development. It skips the starting menu and demonstrates coordinates that you're moving to as well as the direction you're moving towards. And with that, you can also supply a map argument, such as our test map. You can adjust the stepping of the radius of noise, or scale of the noise, or show like a high contrast noise just based off of radius. So, and then with that, you can also supply our Minecraft map, and it gives you the same deal. In addition, we also have debug mode, which gives us a more high contrast grid. Oh, and also we show teleporting. But most importantly, it shows coordinates, grid. You can also add a map as well. So map equals Minecraft, and ta-da!
Hi everybody, my name is Max, and for this project we aim to write high quality and maintainable code. So we use the MVC design pattern across the whole code base, but simplified it a little bit to suit our needs better. And MVC, by the way, stands for Model, View, and Controller. And the game consists of 3 views and a bunch of components. Views combine multiple components together and facilitate the communication between them. Players see only one view at a time, be it the main menu, the map selection view, or the canvas view. Each view and component consists of a single JavaScript class, HTML template, and styles that are scoped to that component. And the common code and styles that needed to be global are located in the lib directory. And the main index HTML is the entry point, which imports all the views. And static directory, of course, contains our textures. All textures for a map are concatenated into a single image to reduce the number of requests sent to a server. But by far the coolest part of the game is the map generation algorithm. So when the game starts, a unique seed is assigned to this map, and the map is generated one block at a time. All random number generators are using the same seed with block coordinates as salt, which guarantees that the map with the same seed would always look identical. For example, if you save the game and reopen it later, the map will look the same. This also allows the map to be infinite in all directions, while having a save file of only like 152 bytes. And underneath, we used an open simplex noise generator. So here is how a single noise layer looks like after we pixelated it. And if we set some cutoff value and scale the layer a little bit, and then overlay 2 such layers on top of each other, they can define the locations of our biomes. So here's how it looks like in practice. And the map definition file contains all the information needed to render the unique biomes. For example, after we partition our map into the biomes, we can add another noise layer and set a step size for it. For example, here we have a basic height map with 3 layers. And in the case of an ice biome, the highest 2 layers are made of snow, with the lowest layer being made of ice. And if we revert the step size back to 1, we get a different noise map that can provide shadows and make some depths in transitions between layers. Finally, if we put a rather low cutoff value, for example like 10 out of 100, and play around with the scale a little bit, we can achieve a noise function for patches of ores and vegetation. And each type of ore has a separate noise layer, so in the end, a single block may involve like as many as 7 noise functions, which are cleverly overlaid on top of each other and combined together. The other cool part is that all noise layers have their parameters adjusted randomly in either direction, depending on the seed of the map. And of course, different layers have their parameters adjusted independently. So in practice, it means that a particular map may have huge patches of diamonds, but almost no emeralds, or a high number of cactuses, for example. All biomes, layers, and patches are defined as JSON objects, and textures are in a single PNG file. So the map generation algorithm can be reused to create wildly different maps by simply replacing the textures and modifying the biome definitions. Okay, I think I might have gotten a little bit too technical there. Let me know if you have any questions, and have a good day.